Hello friends, welcome to the video lecture series on digital image processing. I am Dr. Dafda, and in this 51st video class of DIP, we will study thresholding, global and adaptive or local in digital image processing and its implementation in MATLAB. Starting with the name, what is the meaning of thresholding? Thresholding means the level at which something starts to happen, or in image processing we can say that the level at which gray level change or intensity change starts taking place. So if we subdivide those gray level intensities, we can segment the image or partition the image. The thresholding can be global, where we consider the full image and consider a single threshold point for partitioning, and it can be adaptive or local, where we subdivide the image into small parts and then apply thresholding at a local level. So let us starting with a slide that we studied in our previous video class. We are learning different image segmentation techniques which can be classified as discontinuity based techniques and similarity based techniques. The discontinuity based technique or edge based techniques we have already learned in the earlier classes. Now we will be learning the similarity based techniques or region based techniques such as thresholding and region growing or region splitting and merging. One other similarity based technique is clustering based image segmentation technique. For cluster based segmentation, the pixels in the image are divided into groups where some property of the pixels in each group is similar, or we can say that the cluster of pixels are formed. This clustering based segmentation uses k-means algorithm. This algorithm for image segmentation helps to enhance high performance and efficiency. But we will focus our study only on thresholding in this video class and region based segmentation in the coming video class. This is the slide that we saw in our third video class, namely fundamental steps in digital image processing, where it was mentioned that these two different objects can be segmented separately, ignoring this third shadow by binarizing the image, which will be having only two values, black and white. In the similar manner, this image is also binarized or thresholded, and we have already learned this thresholding function in our 8th video class, namely the basics of intensity transformations and spatial filtering. So this slide is from that video class, and we can see here that if this is the input intensity and this is output intensity S, then all the values above K will be made white, that is 255, S, this is 255, and all the values below K will be made 0 or black. So thresholding is one of the most important techniques for segmentation, and because of its simplicity, it is widely used. The thresholding is used to produce regions of similarity within the given image based on some threshold criteria T. So it is a similarity based image segmentation technique, where based on some similarity we can segment or partition the image into different objects. So the pixels are partitioned depending on their intensity value, and to see different intensity values we use the histogram of the image. So we know that histogram is having different gray level values from 0 to 255 for a 8-bit image, and the total number of pixels on the y-axis. So the obvious way to extract these two intensities or to extract the objects from the background is to select a threshold T that separates the two regions. So if the input image is having such histogram profile, we can have a single threshold T and partition into two different regions, or we can binarize the image. And also, if the histogram profile is like this, we can choose two thresholds or multiple threshold and segment the image. Let us understand single thresholding first. Let us say this coins image is our original image, and this is the histogram of the coins image, and from the histogram profile we can see that we can partition the image into two divisions at around 125 intensity level out of total 255 levels. So now output image g of xy will be equal to 1 if f of xy is greater than threshold. So all the values above 125 will be chosen as 1 or 255, which is white, and if f of xy is less than or equal to the threshold T, that is 125, the output image will be having a single value 0, that is black. So now the single thresholded image will be a binary image as seen here. It is only having two values, black and white. So if this blue bars are the histogram of the original image, then the single threshold image will be having histogram having only two values, white and black, which I have shown using red color. So other than the single thresholding, that is T, we can have multiple thresholding such as T1, T2, or even more than that. So the same coins image which is having histogram like this can be partitioned into multiple threshold by choosing 2T. So if we are choosing T1 and T2, then the image will be partitioned into three regions. So say this is our T1 and this is T2. Then the multiple threshold will be having output such as So as you can see here, there are three colors, black, white, and the third one is gray. And now using multiple threshold, we can even identify the types of coins in the image. Now let us understand different thresholding types. The thresholding operation can be thought of as an operation such that T is equal to T of XY, PXY, and fxy, where we know that fxy is the gray level of input pixel at x, y, and p of xy denotes some local property of this point x, y. For example, say the average level of neighborhood centered on x, y. So from this equation, if the thresholding operation depends only on the grayscale value f of xy, then it is called global thresholding. If along with the gray level value f of xy, the neighborhood property p of xy is also taken into account, then it is called local thresholding. And if t depends on pixel coordinates also, then this local thresholding is called dynamic or adaptive thresholding. So thresholding is called adaptive when a different threshold is used for different regions in the image. So this is called global thresholding since we are using a single thresholding function t for the entire image. And this is called local thresholding since we are considering small neighborhoods and applying different thresholds for different regions of the image. Now the important question arises that how to choose this threshold value t. See, the key parameter in thresholding process is the choice of threshold value, and there are several different methods for choosing a threshold. The users can manually choose a threshold value, or a thresholding algorithm can compute a value automatically, which is called automatic thresholding. A simple method would be to choose the mean or median value. The rationale being that if the object pixels are brighter than the background, they should also be brighter than the average. So assuming that the background and the object occupy comparable areas in the image, a good initial value of t is the average gray level value of the image. And these are the steps for selecting average threshold value. Let us understand global thresholding. Global thresholding is having a single threshold value t, and it is used when the objects are easily differentiated from each other. As we can see in this figure, these two intensities are easily differentiated by choosing a threshold over here, and also these two objects can be easily differentiated from the background ignoring this shadow by choosing some threshold over here. So from the histograms we can see that we can easily use global thresholding as the objects and the backgrounds are separated. But it is also important to take into consideration the role of illumination. Say this is the noisy image which we want to threshold. So the histogram of this image is like this, and from the histogram we can see that it can be easily thresholded using global thresholding. But if this is the illumination that is given to this object, the image that will be generated will be like this. So here we can see that the illumination is non-uniform. So this is the histogram of the non-uniform illumination, and hence the final histogram of this image will be like this, which we can see that we cannot apply global thresholding easily to this histogram, and hence we have to go for local or adaptive thresholding. So the global thresholding often fails in the case of uneven or non-uniform illumination. So the solution is to divide the image into sub-images and determine t for each sub-image. So this method is known as adaptive or local thresholding, as we are applying a separate threshold for each local sub-image. So this is the original non-uniform illuminated image. If we apply the global thresholding, the result will be like this, which is a very unacceptable result. Hence, we subdivide the image like this into number of sub-images and apply threshold to each local region. The output that we obtain is like this. So this result is better as compared to the global thresholding, but still we have a problem over here. So if we zoom these two blocks, the histograms and the output obtained are like this. So how to solve this problem? The answer is further subdivision. So this particular block which is giving a bad result, we have zoomed over here and we further subdivide this image into number of sub images to further improve the quality of thresholding. So out of these blocks, the histogram for this particular block is like this, and application of thresholding to this block will result in desirable output. And now this problem of undesired output is solved over here. But obviously this further subdivision and adaptive thresholding comes at the cost of additional computational complexity. So it will require more processing power as well as time. Now comparing the threshold algorithms, if this is our original image which is non-uniform illuminated as well as having some text, if we apply the global thresholding, the output that we will be obtaining will be like this, where we can see that few portion of the text is recovered but major of the portion is lost. due to global thresholding. So the solution is to apply adaptive thresholding, and this is the result of adaptive thresholding algorithm. Let us implement single and multiple threshold in MATLAB. So this is the program for thresholding where we are implementing single as well as multiple threshold. So the image which we are using is our coins image, and we are applying single threshold as well as multiple threshold. So here we are thresholding into 3 intensity values. We can even choose more as per the requirement. Let us run the program and see the output. Using single threshold, we obtain 2 values, black as well as white, and all the coins are separated out. But when we use multiple threshold, we can even identify coin types. So here there are 3 intensity values, black, gray and white. So that is all for this video class. I hope you would have gained a good knowledge from this video lecture. Thank you very much.